Imagine you're looking at, say, a huge new hospital being built, or
Yeah.
maybe a skyscraper. It's not just the physical structure, is it? It's this just mind-boggling amount of information. Think about everything from the first rough sketch to the very last light switch, trying to manage all that data, keeping everyone on the same page, avoiding mistakes, tracking every detail across the building's whole life. It's huge, enough to make your head spin, really. And that's where something called building information modeling, or BIM, comes into play.
Mhm.
Think of BIM like a building's digital twin, a really smart 3D model. But it's not just graphics. It's packed with all the important physical details, functional data. Everything from day one right through to maintenance years down the line.
Exactly. And it's crucial to understand BIM isn't just a piece of software. It's really a process. It's the way in which the model is produced, shared, and used throughout the entire project lifecycle.
Mhm.
It pulls together design, construction, operations,
Mhm.
all into one digital place.
Right, a process. That's key. But even with this powerful BIM process, you could still end up with a kind of digital Tower of Babel, couldn't you? Everyone using different terms, different labels.
You absolutely could. And that's why we need what you call the unsung heroes.
Mm-hmm.
Classification systems. They're the essential organizers. They bring structure to all that digital information. Without them, BIM,
Yeah.
well, it wouldn't reach its full potential.
So today, that's our mission. We're taking a deep dive into building information modeling and these really crucial classification systems that make it all work. We'll look at systems like UniClass, Master Format, Uniformat, OmniClass, and see how they're not just about labels, but about creating this kind of shared language.
A language that drives efficiency, sustainability.
And ultimately, just better buildings for all of us. And understanding this stuff helps you peek behind the curtain a bit, doesn't it? See how these mega projects keep things accurate, coherent from start to finish? It affects everything: safety, cost, maintenance. Okay, so before we get into the nitty-gritty of classification, let's just quickly level set. What does BIM really mean in practice for the AEC industry? That's architectural, engineering, and construction.
Right. So fundamentally, BIM is a digital representation of a building's physical and functional characteristics. And this information, it's built meticulously, starting from the phase of design to construction and finally operations and maintenance. It includes geometry that are 3D shapes, but also tons of non-geometrical data describing every single element. And like we said, crucially, it's defined as a process. It's about modeling a building virtually with all its info to help design it, build it, and then run it.
A process, not just a final picture. Got it. That's a really important distinction. And this idea, embedding all this rich data, it really started gaining traction back in the late 90s as the tech got better.
That's right. As hardware improved, 3D design software got smarter. It could suddenly store related data about building elements, not just draw lines representing them.
Fascinating. It's a real shift.
Oh, absolutely. What's really interesting here is that BIM marks a historic shift in just fundamental methods. It's not just making a digital drawing, it's connecting all this diverse information. You can simulate construction, simulate operation.
Mhm.
The data itself becomes this incredibly valuable asset. And this whole approach, it's seen as a potential solution to the very fragmented nature of the AEC industry.
Fragmented, yeah. Lots of different players, different stages.
Exactly. So for architects, engineers, BIM helps get the design intent across clearly. For contractors, fabricators, it means smoother implementation on site. But maybe the owners, the facility owners, they're often seen as the most important driver and the biggest beneficiary.
Why is that?
Because BIM reduces risks for them. It gives them a powerful tool to manage the project over its complete life cycle. It changes how they look after their investment long term.
Okay, so BIM is this powerful collaborative blueprint. But then why the need for these classification systems on top? Why not just let everyone use their own tags or descriptions within the BIM model? Doesn't adding another system just complicate things?
Well, that's a really important question. Think about the sheer amount of data generated through a building's life. It's an enormous quantity of data.
Mm-hmm.
And all of it needs to be stored, found, again, communicated, used by lots of different people and companies. And now with smart building tech and BIM getting more advanced, the volume and the detail, it's just exploded, which naturally raises expectations about how valuable that data should be.
Right, like trying to find a specific book in a library with no index system.
Precisely. It would be chaos, impossible to manage effectively.
So more data isn't automatically better data. You need organization.
Exactly. This information explosion demands a solid organizational standard, something that covers everything. It brings certainty to information communicated between parties separated by miles, countries, or continents. Being able to harmonize information, reuse it. That's where the real value and the cost savings from BIM come from. It's at the heart of it. And from the owner's side, facility managers are increasingly saying, look, we need access to all the information for the project kept up to date so we can manage our buildings better.
And it makes the building more valuable later on, too.
Yes, it becomes a saleable asset for future owners because all that history and data is structured and accessible.
And I guess with projects becoming more global, construction products crossing borders.
Absolutely. The increasing international trade in construction products and the diversification of consultant and contracting services makes nationally and internationally accepted principles for information organization of vital importance. It standardizes how everyone talks to each other, regardless of where they are.
Okay, that makes perfect sense. The why is clear. So let's dive into the who and what. Let's talk about these classification systems themselves. We'll look at four main ones, starting in North America, then shifting to a more integrated global view. First up, from North America, master format. This comes from the Construction Specifications Institute, CSI, and Construction Specifications Canada, CSC. Think of it as a master list. It organizes work results, requirements, products, activities. You mainly see it used for bidding documents and project specifications.
Nice, for additional specs.
Exactly, and it's been around a while. Started with 16 divisions back in '63, then grew to 50 divisions in 2004 to cover more innovations. People sometimes call it the Dewey Decimal System of construction. It gives you that standardized outline.
Okay, so master format tells you what work needs to be done, the results. But what about organizing things by the parts of the building? The functional elements. That's where UniFormat comes in. Also North American, also CSI and CSC. Its job is arranging information around the physical parts. They call them functional elements. And it's mostly used for cost estimating, especially early on.
Ah, okay, so less about the specific brick, more about the wall system or the foundation system.
Precisely. Where master format details the brick spec, UniFormat would categorize the whole B-shell, or a substructure. It uses codes, letters, and numbers across different levels to break the project down functionally. Helps you compare costs consistently.
Right. And then kind of building on those ideas, we have UniClass, another North American one from CSI and CSC. This one's broader, isn't it? Its aim is organizing, sorting, retrieving info for all objects across the whole life cycle.
Yes, UniClass is quite ambitious. It cleverly incorporates elements from the others. It uses master format for work results, UniFormat for elements, pulls things together. What makes UniClass really powerful is its structure. It has 15 tables, and each table looks at construction info from a different angle, a different facet. So you've got tables for things like entities, say, a hospital. Spaces by form, like an operating room. Products, a fire door. Materials, steel. Phases, disciplines, lots of angles.
15 different ways to slice the data.
Exactly. It's called a faceted system. Imagine searching your music library not just by artist or genre or year, but combining them instantly. Find me all rock songs genre from the 1970s, FaceTime by female artists. UniClass lets you do that for construction data.
So you could find, say, all fire-rated doors on level 3 of a specific wing using a certain locking mechanism.
Precisely that level of detail. It allows for extremely granular or specific classification, much more flexible than a simple list. It's designed for databases, making information management really robust. As one source puts it, the value is the order it provides. It's the human-facing side of BIM.
That makes a lot of sense. Okay, finally, let's cross the Atlantic to the UK and look at UniClass. This one's designed as a unified system for the entire UK construction industry, covering all sectors. Design, construction, organizing libraries, product info, project info, the lot. It started in '97 but got a major overhaul to become UniClass 2015, led by NBS, specifically to work well with modern BIM.
And UniClass 2015 has a strong international angle, too. It's carefully structured to be in accordance with ISO 12006-2, which is an international standard for this kind of information organization.
So it travels well.
It does. Structurally, it's a hierarchical suite of tables. It can classify massive things like a whole university campus or a road network, right down to tiny details like a single floor tile or a valve. It also currently uses 15 tables covering activities, complexes, entities, spaces, elements, systems, products, tools, project management. A very broad scope.
And the codes look a bit different, letters and numbers.
Yeah, each code starts with 2 letters identifying the table, like S's for systems or PR for products. Then it uses pairs of numbers for groups, subgroups, etc. So you might see something like SS30103025 for heavy steel roof framing systems. And the key thing is it's actively managed. NBS maintains it, updates it quarterly. It's a living system, Now, if we zoom out a bit, these classification systems, they aren't just about neat lists. They're absolutely fundamental to achieving higher levels of BIM maturity, and ultimately they underpin this concept of digital sustainability.
Okay, BIM maturity levels, digital sustainability, big concepts. So what does this progression actually look like? How does it impact the future of buildings and maybe how you, our listener, think about these projects? It's like steps on a ladder, right?
Absolutely. It's a clear pathway, generally seen in levels 0 through 4. Level 0 is basically, well, low collaboration, almost none. Data is mostly in 2D CAD drawings, if that. Information moves around via paper, email, maybe. Very siloed.
The old way, essentially.
Pretty much. Level 1 is where many are today. You start seeing partial collaboration. The key here is usually a common data environment, a CDE. That's like a shared online folder system. You're moving from just CAD towards using 2D and some 3D information, but it's not fully joined up yet.
Okay, getting better. What's level 2?
Level 2 is where full collaboration between different teams really kicks in. The BIM process is properly adopted. Data about the building is shared effectively. Crucially, there's a common data structure allowing different models, architectural, structural, MEP, to be brought together into what's called a federated BIM model.
Federated, meaning combined but still distinct.
Exactly. You can overlay them, check for clashes like pipes hitting beams before you build anything. Huge benefit. Then level 3, sometimes called IBIM, is about full integration. Information lives in a cloud-based environment, ideally using a single common shared model that everyone works on. This is where 6D BIM for facilities management really takes off.
6D, that's adding the time and cost dimensions plus.
Plus the operations and maintenance aspect. Level 3 often involves what's called model transformation. You take the incredibly detailed heavyweight as-it-built BIM model from construction, and you intelligently strip out information that's not needed for day-to-day facility management, creating a lightweight 6D model, easier for the FM team to use.
Makes sense. You don't need the rebar detailing to manage the heating system.
Exactly. And finally, the peak. Level 4, digital sustainability. This describes how that 6D BIM model gets well integrated with smart data from sensors, building systems, etc., within an operational digital environment, or ODE. You're achieving a higher level of intelligence through added information generated from big data analytics.
So the building starts thinking for itself, almost.
In a way, yes. It enables predictive and prescriptive ability. The system doesn't just report a filter is getting clogged. It predicts when it will fail based on airflow data, maybe orders a replacement, schedules the fix. It allows for continuous learning throughout the life cycle of the building management. The building gets smarter over time.
Wow. That's a really powerful vision. Moving from just reacting to problems to actively predicting and preventing them, what are the tangible benefits of climbing that ladder, especially for the folks managing the building long term?
Oh, the benefits for facilities management are huge. Transformative, really. You get increased productivity. Information is faster to find, easier to share, much more accurate, less time hunting, more time doing. It drives efficiency transformation. But this isn't just plug and play. It requires rethinking workflows, changing processes, and critically, changing mindsets. People need to embrace the digital way.
Culture change is always the hard part.
Always. It also fosters an iterative learning process. Every piece of data, every maintenance task feeds back into making the building run better, continuous improvement. And ultimately, it leads to an improved livable environment. You could design and operate more complex and higher quality buildings because you have the tools to manage them effectively. Operations demand higher precision and service quality, and BIM helps deliver that. Smarter, more responsive spaces.
And this isn't just pie-in-the-sky theory, right? We're seeing real organizations using these classification systems now and getting results. Take the Environment Agency in the UK. They manage huge infrastructure, flood defenses, embankments, weirs, thousands of assets.
Massive scale.
They've adopted UniClass. They use it to automate generating asset data via their data requirements library. They're moving away from the old, slow way of digging through drawings manually.
The time-heavy, traditional approach, as they called it.
Exactly. The result, they say it leads to a more informed decision-making process and an optimal use of time and digital automation. Imagine querying the status of hundreds of flood barriers instantly.
Or look at transport for New South Wales and Australia. They had the classic problem, multiple classification systems across their huge transport network. Roads, rail, ferries, all speaking different data languages.
Data silos everywhere.
Right.
Yeah.
So they adopted UniClass to get a single, uniform classification system. It acts as a blanket point of reference. This cuts down the significant efforts and costs to maintain and align all those different systems. They report that time efficiency and accuracy have greatly improved, and it's now vital to its search and retrieve database. That means faster maintenance, better planning, smoother journeys.
And it's not just public bodies. A major construction group like Galliford Try in the UK uses UniClass quite broadly, not just in their BIM models, but across the board to ensure a common language with all their different clients.
Consistency is key.
Yeah. For their ISO 19650 certification, that's a big international standard for managing information over the whole life cycle of a built asset using BIM. Their complex documents, like the Design Responsibility Matrix, are based on UniClass. And get this, they're even using it to handle changes from the new Building Safety Act in the UK.
Ah, that's critical. Post-Grenfell regulations.
Exactly. UniClass codes are being built into their quality check sheets and handover requirements, especially for things like fire stopping and fire performance products.
So it's directly linking classification to safety and compliance.
Right. They cite benefits like a standardized approach, embed further project efficiencies, greater use of digital tools and reporting. It's about efficiency and safety.
Okay, so these systems are powerful and they're being used effectively. But, there's always the practical side. How do you actually use these classifications easily within the design software like Autodesk Revit that people use every day?
Good question. Because just having the system isn't enough if it's clunky to apply, right?
Yeah.
And I gather standard Revit has some limitations.
It does, or it did. Out of the box, Revit had some inherent challenges for classification. For instance, you might assign an UniClass number to a door family. But then all doors of that family type would get the same number, even if one was much bigger or had different hardware, which technically might require a different classification.
No, not granular enough.
Exactly. Plus, the classification databases included by default could easily become out of date or missing key values. Leads to inconsistency.
So to fix that, there are tools like the Autodesk Classification Manager for Revit, and it's a free add-in.
That's right, free add-in. It tackles these problems head-on. It lets users easily organize and manage classification data across multiple Revit models. And it supports the big ones: Uniformat, Master Format, OmniClass, UniClass, and you can even load your own custom database if you need to.
How does it work? Does it make it simpler?
Yeah, much simpler. It uses standard Microsoft Excel files for the classification databases, which are solely configurable so you can keep them updated easily. It also works nicely with another tool. The Autodesk COBie extension COBie helps package up data for handover to facility managers. The key thing is, it lets you assign multiple classification values to elements or types really easily, maybe even with one click in some cases.
Multiple values. So you could tag an element with its Uniformat code and its Master Format code.
Exactly. And it helps standardize things. Instead of people typing fire-rated 1 AOSHR or 1 hour fire rating, it can give you a drop-down list of approved fire rating values to pick from.
Yeah.
Ensures everyone uses the exact same term.
Consistency again.
Right. Users basically pick their database, select the thing in Revit they want to classify. It could be a wall, a door, a pump, and then they navigate this simple tree structure showing the classification codes, pick the right one. Done. Much cleaner.
Okay, so the tools are getting better, bridging that gap between the system and the software user. It really does sound like a powerful path forward. But it can't all be smooth sailing. What are some of the hurdles still out there, and where are these systems heading next?
Yeah, there are definitely challenges. One big one is trying to implement a system like UniClass mid-design. Ideally, that decision gets made right at the start, written into the BIM execution plan.
Trying to change course halfway through a project? Tricky.
Very. It can mean a lot of rework, renaming, renumbering, depending on how far along the project is, how detailed the models are. It could even mean additional fees to sort it out. And then there are the perception barriers. Greg Seaton from CSI mentioned this. Users presume these are difficult to implement. That fear, whether justified or not, can really slow down adoption. It's a human factor.
The "it sounds too complicated" factor. Got it. So changing minds is key. What about the future direction? Are we heading towards one global system?
That's a big debate. Roger J. Grant from NABS in the U.S. actually argues against one single global system.
Oh.
He thinks having one overarching international classification management system is not a good option.
Oh, okay.
Because needs vary so much regionally.
So what's the alternative?
He suggests what we need is to map various national classification management systems, Basically, create translation keys between systems like UniClass and OmniClass so data can flow smoothly across borders even if the underlying codes are different.
Interesting. Interoperability through mapping, not necessarily uniformity.
Exactly. There's also ongoing work tying classification management systems with Industry Foundation Class, IFC.
Hmm.
IFC is that neutral file format designed to let different BIM software talk to each other. But even IFC isn't perfect. It still faces its own challenges during implementation, when intelligent information is lost as data moves from one software to another. So refining that link between classification and IFC is important. And the systems themselves keep evolving. Like we said, UniClass gets quarterly updates from NBS. They have future plans to constantly evolve its offering. There's an advisory board continuously improving the system's capabilities to drive up construction quality.
So they're not static.
Not at all. And research continues. Future studies need to look at better ways for comparing and mapping between classification systems and their integration with BIM. But despite all the challenges, the commitment is there. Organizations like CSI have stated they will keep maintaining master format, uniformat, and OmniClass in the future. They recognize the foundational value.
Okay, so wrapping this up, it's clear these classification systems are much, much more than just bureaucratic lists or codes. They're really the essential shared language, aren't they? Bringing order, efficiency, collaboration to the incredibly complex world of BIM. And they're paving the way towards that future of true digital sustainability in the places we build and live. So as these systems keep evolving, getting smarter, integrating more deeply with digital tools, it leaves us with a pretty powerful thought, doesn't it? A question for you, listening. How might this ongoing quest for a truly unified, intelligent language for our built environment fundamentally change things? Not just how we build buildings, but maybe what kinds of buildings become possible to build and manage sustainably? Could it unlock new levels of smartness, safety, resilience, creating better places for all of us for generations to come? Something to think about.